Okay, so there are a couple of thoughts that I'd like to leave you with today, and one of them is, and you'll hear a lot about air quality, obviously that's a key focus, but it's not that our air quality is getting worse. I'll show you some slides that show that our air quality is actually improving with population. It's that the measures that we grade against are getting more stringent. And this is really a key point. I think Carl Edlund had some slides up showing that there may be new non-attainment areas in the future. That's not because those areas are getting worse in air quality, it's because we're lowering the levels at which we grade those areas against. So that's critical. It's also critical to recognize that those improvements in air quality are happening while the state continues to have growth in population, and with people come cars and electricity demand. And that's really the heart of the air quality challenge moving forward, is how do you balance the future growth we see both in the electricity demand and the consequent increase in emissions, and the increase in emissions from, or the potential to increase emissions from increasing population and everything that comes with that, with these tightening air quality standards. And then, so I'm going to talk a little bit about air quality and where we are, and I'm also going to talk about one of the things that we do in the state of Texas, one of the programs that we're looking at addressing mobile emissions. So a little different take on energy efficiency. First, by way of background, the Clean Air Act, the Federal Clean Air Act, has 6 pollutants that are regulated, that they set national ambient air quality standards for: ozone, particulate matter, NO2, SO2, carbon monoxide, and lead. The good news is that in the state of Texas right now, we only really have to deal with ozone non-attainment areas. But with every pollutant, the EPA is required every 5 years to look at those pollutants and ask the question, do we need to tighten this standard? And if the answer is yes, we need to tighten the standard, then the result is that you may have new non-attainment areas. So the focus right now is ozone, but that's not to say that we won't be addressing issues with the others in the future. So ozone is a very talked about pollutant, and one of the reasons is that it's gotten a lot of focus is that EPA continues to lower the standard. So we started out with a 1-hour standard that was the equivalent of 120 parts per billion, or if you were over 100, if you were 125, then you rounded to 0.13 parts per million, and so you were violating the standard. Recently, in recent times, in 1997, they lowered it to 0.08. You'll hear it talked about as the 85 part per billion standard, because if you're at 85 or more, then you're exceeding, and if you're below, then you're not. Well, in 2008, they added a significant digit for those engineers in the crowd. So now it's the 75 part per billion standard. And for the old standard, the 0.8, or the new one, Houston and Dallas remain the non-attainment areas. Particulate matter is an issue in El Paso, and a lot of the challenges in El Paso come from natural events, windstorms, but also from pollution that's carried across the international border. And those are issues that we don't necessarily have the ability from the state perspective to address. As far as lead goes, there's a very small portion of Collin County in Dallas-Fort Worth that is non-attainment, and that is largely attributable to a battery recycling plant at the center of that area. Okay, so here it is pictorially. Again, Carl Edlund had a lot of other areas of concern, but these are the non-attainment areas in Texas. So these areas have been designated by the EPA as not meeting the standard. So why aren't they meeting the standard? Well, when we look at developing what's called state implementation plans, or SIPs, we develop inventories of where the emissions are coming from. And is this a, oh, nope, go back. Yes. So what's notable is the 2008, and by the way, we do these very comprehensive inventories where we look at all of the sources every 3 years, but we do collect industrial emissions every year. So that's why we're looking at 2008 here to account for all of them. So when we look at where we see NOx emissions, and by the way, NOx is a precursor to ozone, that's why we regulate it, and we found both in Houston and Dallas that there are plenty of volatile organic compounds that contribute to the formation of ozone, and it's really, if we get NOx under control, we see reductions in ozone. So you see that the mobile emissions in the Houston area are 71% when you add on-road and non-road mobile, 71% of the NOx emissions now. Now, if I put up a chart from a few years ago, you could see that industrial sources were a key, were a larger piece, but that's not true anymore. The difficulty here is that, and here's Dallas. The difficulty here is that the state of Texas, who's responsible for writing these state plans to get the areas into attainment, to meeting the standard, don't have the ability to specifically write emission standards for automobiles. Now that makes sense, because if every state could do that, then you'd have 50 automobile standards, and that would really mess up the car industry. Also with engines. So what do we do when most of our problem is coming from mobile sources, when the state of Texas is responsible for writing these plans, and yet we have so very little that we can address? And another point of interest, since it's come up a couple of times, this area source 26 in Dallas, you can look back at Houston and see that the area sources are 5%. This is 2008 in Dallas-Fort Worth, and a lot of these area sources of NOx are from the Barnett Shale. So in 2009 and 2010, there are some significant emission reduction strategies that have gone into effect, and there's about a 90% decrease in the area source emissions that we expect to see. So once we finalize the next national emission inventory of all of the sectors, we should see that the 2011 percentage goes down on the area sources. Okay, this is a busy slide, but what's important to note here is the general trend. What these specific lines are the design value, how we determine whether you're attaining the standard from 1991 through 2011. The top line is the Houston area. That's not surprising, since we saw since we've seen that the very large industrial complex in Houston have a large piece of the responsibility for making emission reductions, and they have. And I'll show you that in a minute. But you can see that in general, the trend line for all of the areas in Texas is going down. The gray bars in the background are population. So as we see the population in Texas increase, we're still seeing air quality improve. Now the problem is that here are your standards. This is the 1997 standard of 85, and this is the latest standard of 75. So you can see that all these areas were hanging out below the standard before, and now have a new challenge in the 75. The other thing is that we're looking ahead, and the next ozone standard that will be put in place is expected to be proposed in 2013. So where is that going to go? Well, we've heard that EPA is looking at anything from 70 to 60 or 65. So if that happens, you can see how all these areas that have seen air quality improvement over the years are now going to be thrust into potentially non-attainment because the grading standard has changed, not because they have gotten dirtier. Okay, so let's talk about just industrial sources in general in all industry sectors. Now this is, so this includes your power plants, this includes your refineries, your chemical industry, all of that. From 2000 to 2010, we've seen a tremendous reduction in NOx emissions. These reductions have come about as the state has put into place the state implementation plan. They've come about as those particular plants have made their own improvements and upgrades. So in Houston in particular, here is a 1 hour design value. Now, the ozone standard used to be averaged on a 1-hour period, so you looked at those peaks, but now you look at a rolling 8-hour average to determine if you're in compliance. And you can see that has gone down as well. Now, 2011, we've already talked about, and anyone who was here last year knows what kind of summer that was. So what we saw was that with the increased temperature, the stagnant, that high pressure system that just sat over Texas and the wind didn't move, well, when the air is still, that's the perfect opportunity for, with sunlight, still air, and you've got emissions coming from the power plants and everything else that is going on an average day that all cooks up to make ozone. So we saw an uptick in a number of areas. Here's in Houston in particular, NAAQS trend for industry sources. Remember the pie charts I showed you earlier. Mobile sources are a real issue. Here's another way to look at how air quality has improved over time. Now, I know these numbers are small, so I'll tell you that the red numbers peak out at about 111 parts per billion, and the blue numbers peak out at 73, 75. So here's 2000. What we did here is we looked at the monitors that were in the Houston area, which we have a number of ozone monitors, and we extrapolated and interpolated basically to say if we had a monitor in everyone's backyard, what ozone concentration would they be experiencing? And you can see the tremendous reduction in ozone that's gone from the 111 down to the 70s. The problem is, again, that if EPA drops now the standard is dropped to 75, but if EPA drops the standard to 65 or even 70, all of this area is now in jeopardy of being non-attainment. And another key point about how something is determined to be non-attainment is it only takes one. So you have one monitor that is showing it's not attaining, and the entire area is designated as non-attainment. So let's talk a little bit about the state implementation plan and how we look at energy efficiency. Well, we know that energy efficiency can have a tremendous impact on emissions reductions. The problem is when we look forward and are writing a plan, we predict emissions, we predict what growth factors in industry and how those emissions, if we had the same weather, would affect the ozone concentrations. So if we assume that a certain amount of energy efficiency will reduce emissions, and we can't guarantee that in the future, then we have an obligation, sort of like if you promise the IRS that you are going to pay a certain amount of taxes, but you don't pay them, then that comes due on April 15th. So in the same way, if we make a commitment and a promise in our SIP, then we'll have to come up with those reductions if our predictions don't pan out. So when we look at including energy efficiency on our state implementation plan, we have something called weight of evidence. And the weight of evidence is basically we use models to make predictions of what we think the ozone will be in the future. And then we look at factors that we didn't explicitly include in the model and ask the question, does that support a belief that the strategies we put in place will improve air quality, or does it not? And so energy efficiency is one of those places that we can say we didn't account for it in our specific model, but we can assume that that's going to help. And when you look at the numbers on the ground, energy efficiency will help. The problem is also that with the interconnectivity of the grid, just because one area has made a reduction in how much energy it uses, that doesn't mean that someone else didn't pick that up and the power plant that is providing that electricity is still operating at the same level. So EPA put out this guidance document, and as I kind of alluded to, the reductions have to be enforceable, permanent, quantifiable, surplus, and that is true of anything that's called a SIP creditable reduction. So whenever we make those future predictions, we have to put limitations in place that guarantee that those reductions will be made in the future. I already talked about weight of evidence. I'm going to try to move along a little bit because I have more slides than I have time. This is a different view of something you've already seen a couple of times, not quite as colorful as the slides from PUC's executive director or ERCOT, but simply the firm load forecast, the reserve margin added to it, and what resources we see. So why is it important as far as the Pollution Control Agency is concerned? Is that if we begin to see those base load units come offline because of regulation or for whatever reason, then we start to jeopardize our safe, reliable electricity in the state of Texas. So the things that we're particularly concerned about, and anyone who spends any time looking at how Texas and the federal government are getting along, knows that we have protested some of their regulations of late. And we're very concerned. We just recently won a lawsuit regarding the cross-state air pollution rule. We were very concerned that that would affect the reserve margin and reliability. Another concern we have is the mercury air toxics rule and the carbon pollution standard. How those rules affect, the carbon pollution standard is for new generation units, but the mercury air toxic standard affects both existing units and new units. There are some planned units that are going to go into, that are expected to go into play, but now that the mercury air toxic standard came out, now they have to meet a new set of rules that are not consistent with their permit. So that's why you see a lot of litigation about that rule as well, because that may have a significant effect on whether those plants actually get constructed and begin operation as they had intended. Drought, there's been a lot of talk about that as well. I think the important thing to know regarding drought is that water is important, especially for power plants, cooling systems and things like that. And the state of Texas, we've worked very, very close, the different agencies together to address those emergency situations where an environmental reg may get in the way of being able to handle some emergency issue. So I won't go into detail about that. The Texas Emission Reduction Plan. So I mentioned earlier about mobile emissions and how that's a great concern, and one of the things that our legislature did for us a number of years ago was they created the Texas Emission Reduction Plan. And what TERP does is it provides grants to engines, motor vehicle, diesel engines, to replace them with newer units and have a measurable decrease in emissions from specific mobile sources across the state. There are, oh look, here's a description. TERP is not explicitly funded by the taxpayer. It is funded through the through fees on the diesel truck 18-wheeler registrations in Texas. A portion of that fee goes into the TERP fund, and so then that comes back to those owners to be able to, in the form of grants, to be able to upgrade that equipment and hopefully see a dent in the mobile emissions. So TERP functions in all the non-attainment areas and the near non-attainment areas, and there are specific highways that if you operate on those highways, you can count that mileage for TERP. We've seen almost 9,000 projects, 14,000 activities, tons of NOx reduced, 165,000 tons, and we passed out $850 million of grants. So a lot of money has been spent in this area. And in fact, this program is nationally regarded, and there have been other programs that have have looked to us to figure out how did we do this, because it is important. Okay, so with regard to where we funded this, because Houston and Dallas are our biggest air quality concerns, it's not surprising that they've received the lion's share of the funding. There are a couple of new grant programs, and I'll talk about those. These are all of the programs that come out of the TERP grant. The Clean Transportation Triangle is basically a grant program to help develop natural gas fueling stations within the interstate highways of Houston, San Antonio, and Dallas. The idea being that you can't incentivize people to move towards natural gas if they can't guarantee that they'll have fueling stations. So this program works with another program and hoping to build that natural gas vehicle usage in Texas. So if a station is going to provide compressed natural gas, they get $100,000, $250 for liquefied natural gas, or they're eligible for $400,000 if they provide both CNG and LNG. These fueling stations have to be available to the public. So, for example, a company can't replace all their fleet with natural gas and then get grant money and then only use it for themselves. They have to provide the opportunity for the public to use that fueling station as well. There's another program called the Alternative Fueling Facilities Program, and this addresses all alternative fuels, or not all. These are the eligible fuels: biodiesel, hydrogen, methanol, natural gas, also propane, electricity. So this fueling program is, the purpose of this program is to develop fueling stations for these alternative types of fuel, so that, again, if you wanted to pursue that type of fuel in your vehicle, you wouldn't have the detriment of not being able to get fuel for your vehicle. The Texas Natural Gas Vehicle Grant Program is the vehicle part of the triangle. So basically this is a grant program to replace those vehicles with natural gas. And the new vehicle or engine has to get 75% of its power from compressed or liquefied gas, and has to show a reduction in NAAQS. Remember, NAAQS is our pollutant of concern. And it also works through the dealers. So we basically get a partnership with a dealer for the natural gas vehicle, and they go through the eligibility process to make it work well for the customers. So we have some grant rounds that are open right now. We just closed the Clean Fleet and the alternative fueling applications, and those are being reviewed. We still have all the others are open right now. The Clean School Bus Program is not open for a grant right now, but probably will be. And if you have any questions, we have a huge website and lots of staff that are available to help you with that. So as far as funding goes, the majority of the funding has gone towards the emission reduction incentive. This is the traditional TERP grant program, $29 million. And then you can see the breakdown. The natural gas vehicle grant program is $9 million, and on and on. The regional air monitoring program, at the last legislature, because of concerns about the Barnett Shale, there was a specific piece of legislation that took a little slice off of the TERP program to fund monitors in the Barnett Shale region. So we put a number of air quality monitors up there that have been a result of the funding from this program. And that's me. Be happy to answer any questions, or you can email me if you like. That's all I have.